Module 4.1, Linear Functions and Equations of Lines, sections 2.4 and 2.5 in your book. 4.1 Opener. In this section, we're going to expand the study of functions and equations by looking at linear functions and studying the equations of lines a little bit more in detail. Some concepts you should focus on. You should be comfortable working with and finding the slope of a line. You should be comfortable working with both the point slope form and the y-intercept form of an equation of a line. Two different forms that are very important. Linear functions in standard form. Definition. A function is linear if it can be written in the form f of x is equal to ax plus b. And this is what we usually call the slope. The standard form of an equation of a line is ax plus by is equal to c. Notice that here there's still like a ax, there's like a y, this used to be your y, and this is like your c. So it's the same type of, it's the same thing, it just looks a little different. So just two different forms of writing the equation of a line. The domain and range are the same as stated before. Again, so the domain is still what x values are allowed, and the range is still what comes out for the y values, or for f of x. To find x and y intercepts, you go through the same process as before. There's no difference here, just because we're talking about linear functions. So we're going to find the x and y intercepts again to see if you can remember how to do that. So x-intercept, remember the first thing you should think of when you see x-intercept is set y equal to 0. So that's what we're going to do. 2x plus 3 times 0 is equal to 6. So 2x is equal to 6. So x is equal to, remember, divide both sides by 2, is equal to 3. Y-intercepts. Remember, set x equal to 0 now. So 2 times 0 plus 3 times y is equal to 6. That's 0, that's 3y is equal to 6. When you divide both sides by 3, you get y is equal to 2. Okay, so your x-intercept here is 3 for x, 0 for y. Your y-intercept here is 0 for x, 2 for y. Right? Remember, because we set x equal to 0. We set y equal to 0. The slope. The slope of a line is just the rise over the run. So if we were to look at the graph of any line, the slope between any 2 points is how far it goes up and then how much it goes over. Right? Just like you would think, that's this slope right here. How far does it go up and how far does it go over? Okay. We sometimes say that's rise over the run. The rise is the change in y values, and the run is the change in x values. What do I mean by change in y values, change in x values? Notice that from here, from this point right here to this second point right there, there's a y value, we can call it y1, and there's another y value, y2. The difference between those two is the change. So y2 minus y1, to keep it positive, that's the change. Same thing for the x's. From here, from this point to that point, there's an x value, we can call it x1, x2. So that distance is the change, and it's just x2 minus x1. So the slope of a line, m, as we usually call it, can be given as rise over run, or the change in the y values. So it could be given as y2 minus y1 over x2 minus x1. So if you have 2 points, x1, y1, and another point, x2, y2, then you can always find the slope. Just subtract the y values, subtract y2 minus y1, and then subtract the x values, x2 minus x1. Horizontal lines have 0 slope. So horizontal lines, in other words, lines that are level to the ground, like this line here, have a slope of 0 because they don't have any rise, right? They have run but no rise. Vertical lines, in other words, lines that are completely perpendicular, perpendicular to the ground, have a slope that is undefined. By perpendicular, I mean that they make a nice right angle to the ground. But here we have slope 0 because the rise is 0. And here we have a slope that's undefined because the run is technically 0. In other words, there's no change in the x values here. So as an example, I can give you the points 1 for x, 2 for y, and then again 1 for x, 5 for y. If you were to calculate the slope, here you would do y2, which is 5, minus y1, which is 2, over x2. I'm going to label them here, y2, x2, y1, x1. So over x2, which is 1, minus x1, which is 1. So we have 5 minus 2, which is 3, over 1 minus 1, which is 0, which is undefined. It's not equal to being undefined, but we say that that is undefined because we're dividing by 0 here. Let's try one more. Give you the slope, the points 1, 2, and then let's make something else for x2, and let's say 5 again for y. Again, m is equal to y2, y2 is still 5, this is x1, y1, x2, y2. So 5 minus y1, 2, over x2, 2, minus x1, 1. 5 minus 2 is 3, 2 minus 1 is 1, and 3 over 1 is just 3. Working with point-slope form versus slope-intercept form. The point-slope form of an equation of a line is given to you by y minus y1 is equal to m over, or times x minus x1. In other words, you're given a point and a slope. You're given 1 point, x1, comma, y1. And you can use those values and the slope, you're given the slope, to find the equation of a line. The slope-intercept form of a line, in the slope-intercept form of a line, you'll have to usually find the slope m. So you'll need an x1, a y1, an x2, a y2, and you'll have to use that to find a slope m, and then you have to still find that y-intercept b is what we call it. So in the slope-intercept form, this m is the slope, and this b tells you what the y-intercept is. The y-intercept is always going to be 0, comma, b, just like we found before, right? The y-intercept, remember, is where the graph of the line crosses the y-axis. And we'll look at some examples here in a bit. Okay, but there's always some work to do in whatever form you're working with, so you should know both of these. There's no better form. They're different. Write the equation of the line through 1, 1, and 2, 3. The equation of a line. Well, we can try either point-slope form or slope-intercept form. Let's try point-slope form. Y minus y1. Let's say this is x1 and that's y1 there. Okay, it doesn't actually matter. So y minus y1 is 1 is equal to m, which we haven't found yet, times x minus x1 is 1. So we'll have to do some side work. Remember, you should be using scratch paper all the time. Side work. Remember, the slope m, because we need it here, is equal to y2 minus y1 over x2 minus x1. Again, that's x1, y1, x2, y2. So it's 3 minus 1 over 2 minus 1, 3 minus 1 is 2, 2 minus 1 is 1, so the slope is 2. So I can go back here and say y minus 1 is equal to 2, x minus 1. And if you wanted to write this in slope-intercept form, you can. Remember, slope-intercept form is mx plus b. It just has y is equal to mx plus b. All you would have to do is simplify that. Add 1 to both sides. So you'd get, and multiply this out, 2x minus 2 plus 1. So you'd get y is equal to 2x. Negative 2 plus 1 is negative 1. And there's your slope of 2, just like before. And this tells you that your y-intercept is 0, negative 1. Finding parallel and perpendicular lines. Two lines are parallel if they have the same slope. Okay, if you have two lines, y is equal to 2x plus 3, and another line, y is equal to 2x minus 5. Because they have the same slope, they are parallel. In other words, if we were graphing them, there's line 1 and there's line 2. It doesn't matter how far out we go, these two lines would always be separated. They would always be separated by the same distance because they have the same slope. Two lines are perpendicular if the slope of one is the negative reciprocal of the other. So if we have y is equal to 2x plus 3, and the other line is y is equal to not 2 but 1 over 2. In other words, you flip the fraction. This fraction can be thought of as 2 over 1, and we flip it and make it negative. So negative 1 over 2 plus x, plus 3, or plus whatever. So that would mean that you have one line that has a slope of 2 and goes through the point 3, the y-intercept of 3. Let's say that's 3. And then this other line has a slope of negative 1/2 and goes to 3 still. And they make a right angle. Find the equation of a line that is perpendicular to 2x plus 3y is equal to 12 and passes through the point negative 1, 0. So perpendicular means we're going to have to find the slope of this line first, of 2x plus 3y is equal to 12. Okay, so what is the slope? It's not always the number in front of x, right? It's only the number in front of x if we have the equation in the form y is equal to mx plus b. But that's not what we have. But we can do that by subtracting 2x from both sides. If we subtract 2x from both sides of the equation, we get 3y is equal to 12 minus 2x. If we divide by 3 now to everything, divide by 3, divide by 3, divide by 3, we get 4 minus 2/3 x. So if we're trying to find an equation that is perpendicular to this line, our slope needs to be the negative reciprocal. It needs to be positive 3 over 2. Okay, so we need y is equal to positive 3 over 2x plus b. And this is where this extra point comes in right here. We don't know what this b is, but we need to know what the y-intercept is. So we're going to use this x value and this y value. So when y is equal to 0 and when x is equal to negative 1, this is equal to 0, this is equal to negative 3/2 plus b. And we can add 3/2 to both sides. And that will give us that b is equal to 3/2. And there we have our equation of a line that is perpendicular to this line and passes through negative 1, 0. The equation is y is equal to positive 3/2 x plus 3/2. A horizontal line has an equation of the form y is equal to b. In other words, if we were to graph a horizontal line, notice that the x is all changed. X can be 1, x can be 2, x can be 3 for all these points here. But what's one thing that stays constant all throughout? It's the y value. The y value here is always some number. This could be 1, 2, 3. Then the equation of this line would be y is equal to 3. Because it doesn't matter what x is. The only thing that has to be true is that y has to always equal 3. A vertical line is similar, but what's the one thing that stays constant here? The y values are different, but what's always the same? The x value. This could be 1, 2, so the equation of this line would be x is equal to 2. The only thing that matters is that x has to equal 2 there. The only thing that matters here is that y has to equal 3. Now pause the video and try these on your own. Alright, we need to find the line that is parallel to x plus y and goes through the point 0, 1. So we need the slope, and because we need it to be parallel, we need it to be the same slope. We want it to go through the point 0, 1, so that's going to help us find the y-intercept, which is b. Alright, so let's find the slope of this equation. If we write y is equal to 5 minus x, in other words, if we subtract x from both sides, we get the slope is, again, always the number in front of x, is negative 1. Again, we want a parallel line, so we want the same slope. So we want something that looks like y is equal to negative 1x plus b, and that b is going to be found by plugging in 0 and 1. Plug in 1 for y and 0 for x. 0 times negative 1 is 0. So that tells us that b has to equal 1. And that tells us that our equation of a line is y is equal to negative 1x or negative x plus 1. That's the line that's parallel, has the same slope, and goes through 0, 1. Give the definition of slope. Remember, slope was always y2 minus y1 over x2 minus x1. And that's for 2 points, x1, x1, y1, x2, y2. Alright, you should now be ready to start homework 4.1.